So now that we've gone through the first two levels of basically utilizing the properties of logs that we talked about, now we're going to be using those properties of logs to solve exponential and log equations. And the one property I didn't mention, and it's not really a property, it's more of an equivalent, call it a statement. So when you have a base and you raise it to the x power, or to any power, and you set that equal to some number. So we have base raised to some power, exponent, equals some number. Well, that's called an exponential equation because it has an exponent in it. It's an exponential equation. The variable's up there in the exponent, or it's just an equation that involves exponents. And so if we want to rewrite that same equation using logs, this is absolutely your bread and butter. The base is b in the exponential equation, and then the base is b in the logarithmic equation. The exponent is a log, so whatever the exponent is going to go on the right side of the equals sign, and then the only other number here is y. So basically, we can rewrite this exponential equation using logs. B to the x equals y is the same relationship between these three letters, variables, numbers, as the relationship that they have in the logarithmic equation. Okay, so we remember that, just a quick example, we know that the log base 2 of 8 has a value of 3 because it takes 2 multiplied by itself 3 times to get to 8. In other words, 2 to the third equals 8. So if you just want to remember that and then convert that to exponential form, then, you wouldn't say 8 squared is 3, you wouldn't say 3 to the 8th is 2, you wouldn't say 3 squared is 8. None of that works. 2 cubed is 8. So if you look at a logarithmic equation and you want to convert it to exponential, maybe just write that down and then write down the 2 to the third equals 8, and then you'll have your relationship on where all the numbers go. So in other words, how does that help us? Right here, 2 to the x equals 8. This is an exponential equation that we want to solve, and we want to figure out what the value of x is. Well, if we want to figure out the value of x, I kind of got ahead of myself there. When we solve exponential equations, and sometimes we convert to logs, which we can. However, easier if when you look at the exponential equation, if both sides can be written as a power of the same number, which in this case it can, both sides can. Both 2 and 8 can be written as a power of 2. When you can do that, this would be an exception to the rule of you don't always have to convert exponential to log form, but just like this Punnett square, we've talked about this. If the bases are the same, that means the exponents have to be the same. So x then has to be equal to 3. And so this kind of goes back to you have to know your properties of exponents then to be able to solve these exponential equations. In other words, when you see 3 and you see 1/9, what you should be thinking, what would be really helpful to be thinking, is 1/9 can be written as 3 to the negative 2 power. Now again, 1/9 is 1 over 3 squared, and 3 squared in the denominator is 3 to the negative 2 in the numerator. All right, so that's a couple properties there of real numbers. And then again, now that we have both sides written as a power of 3, we would equate the exponents. X is equal to negative 2. All right, then we get probably the most challenging one, and a super kind of common type of exponential equation that you would see in a section like this would be where you have to recognize that 1/2 can be rewritten as 2 to the negative 1, and then 32 can be rewritten as 2 to the 5th power. So what we want to do is we want to rewrite each of those numbers, 1/2 and 32, as a power of 2. So once we do that, we can still raise those numbers to the exponents by using the other property of exponents, and that is when you have power to a power, we multiply, and so we can rewrite the left side as 2 to the negative 1 times 2x, which would be negative 2x. The right side, exponent to power to a power. Again, so when we have power raised to another power, we're going to multiply those. 5 times x minus 1, be careful because you're going to have to multiply the 5 times the whole quantity x minus 1, which means you have to distribute the 5 to the x and then distribute the 5 to the 1, to the negative 1. And therefore you get, now you have the left side and the right side as a power of 2. So then you just equate the exponents. Negative 2x is equal to 5x minus 5, and I didn't leave myself a whole lot of room here. Let's kind of cruise down here. Let's do this all at once. If we add 2x to both sides, that's going to make the right side equal to 7x. And then if we add 5 to both sides, that's going to make the left side equal to positive 5. All right, and then if we divide both sides by 7, we get x is equal to 5 over 7, and it's okay if you have the x on the right hand side. It's not going to change the fact that x is equal to 5 over 7.